Okay, on to question 3. So students investigating 2 different lamps here, and I think the big mistake people made is they thought both lamps needed to be in the same circuit, which they don't. So first bit, complete the circuit diagram to figure out how the student could have obtained the results. Okay, so what we're going to need here, well, we're obviously going to need the bulb. So there's the bulb that we're investigating. And we're going to need in this circuit as well, we're going to need an ammeter to measure the current through that bulb. And while we're here, let's do a voltmeter as well to measure the voltage across the bulb. Think about our graph, we're measuring voltage and current, so we need those 2 devices. But we're also going to change the current and the voltage in the circuit, and so we're going to need one more thing, and that's a variable resistor. And so actually what we're going to be doing, we're going to be changing this, changing the value, and that's going to give us different currents and different voltages. If you want to investigate this yourself, I'd encourage you to go and play with the FET simulation, build the circuit, and see how you could collect these results. Which lamp will be brighter at any potential difference? Okay, so looking at it, we can see that A has always got a higher current for the same voltage. It's really important that we try and say that it's always at any voltage. So A is brighter. Why? Because it has a higher current at any voltage. Well, let's say any given voltage. You know, so comparing them fairly, like compare them both at 6 volts, like I've done here, compare them both at 10 volts. This is 1 point. Now I need to link this idea of brightness to current. How am I going to do that? Well, that's going to be my power equation. Power equals current times voltage. So if current is higher, power will be higher. And try and think about, what does power mean? Power is the energy per second. So this is the energy used per second. So if it's using more energy per second, it's going to be brighter, right? And that's how we answer that one. Lamp B has a higher resistance at any potential difference. Explain how the figures show this. Well, for the same PD, so let's just shorten this potential difference to PD. For the same PD, lamp B always has less current. And then I think what I would do is I would argue, well, if R equals V over I, if I is smaller, R must be bigger. Again, you've got to think about the way the maths works here. Like, think about dividing by a smaller number, you end up with a bigger number. So if I is really small, then that means that R gets really big. Sometimes I like to draw arrows on here. So I gets really small, that means that R must go really big. You can play with that in your calculator, test what happens when you divide by different numbers. Okay, next question. Both lamps behave like ohmic conductors. So what does that actually mean? Well, if it's ohmic, it means that current is directly proportional to voltage. In fact, let's write that down. Ohmic means current is directly proportional to voltage. Okay, so what are we looking for on the graph? So look for a straight line through origin, because that's how we know, if something's directly proportional, it's a straight line through the origin. So let's look at our graph and say, are they straight lines through the origin? And you go, oh, well, not really, but actually, if we zoom in, they kind of are at the beginning, right? So now we've got to make a judgment. So let's look at the first one, lamp A. How far is that a straight line for? Well, I'm going to say it's a straight line like that long. Maybe you could argue a bit higher, but seems reasonable, right? It's a straight line up to there. And what about the other one? Let's do the other one in another color. The other one, maybe a straight line up to about there. Something like that. Again, using your judgment. Maybe a little further. Maybe up to like there. So if we're talking about the... And you know what? Looking at that green one, I'm thinking I can probably argue it's up to there, right? Straight line up to about there. So how far are these? Well, the green one, you know, looking at that green, I'm like, maybe even further. Maybe like there. And the thing is, it's not too important, like as long as you can justify your answer here. So I'm going to say from there to there and to there. And that way they're both about the same. So looking at the range, that range is from about there to about there. So that's from about 0 to 1.4 volts. I could argue that this is directly proportional. So going back to the question, because it says, what's the range where they're ohmic here? Back to the question, I would say they are ohmic between 0 volts and 1.4 volts. Because that's where they're straight lines. At least that's what I think. That's what it looks like to me. That should give you the marks. We could also say resistance is constant in this region. Resistance is constant in this region. All right, and that is the end of question 3.